Okay, good afternoon all. Welcome to the e-learning session today, and this session is going to be on DNS security. Now, my name is Champika and I work as the training manager at APNIC. So I would be delivering this session for the next 1 hour. Now, before I start the session, I would like to know whether you can hear me properly and whether you can see me properly. So if you can see me properly and if you can hear me properly, could you please type onto the chat window so that I know exactly whether you can hear me and you can see me. Thank you. I am getting some responses. I got 2 responses so far. There are a few more participants already logged in, so I will wait for another few seconds just to make sure that everyone can hear me. Okay, that's good. It's good that I'm getting some few more responses, so it looks to me that it's all right from this end, so we will start the session. And in case if you encounter any problems, please write an email to training@apnic.net, so that we can try to sort out those problems, and hopefully you can resolve in case if you encounter any problems. But other than that, I think it looks all right to me. So let's get started. Now, as I said earlier, so this session we are going to focus more on the DNS security. There are some assumptions. For example, we do assume that you have some understanding about DNS, general concepts of DNS. Because in this session we will be talking a bit more advanced concepts which are related to security aspects of DNS. In case if you are not familiar with the DNS concepts, then we do have other DNS courses, e-learning sessions. You may be able to follow those. Those sessions will be coming in different sessions as well. If you look for the e-learning schedule, you should be able to follow through those sessions. So as I said, my name is Champika. So that's I'm glad to basically do this training, and very nice to meet you all. Okay, now first of all, let me try to recap what how the DNS query works, because we need to understand how these DNS queries work, and then we can talk about the security aspects. Now, usually what happens, as you can see in this diagram, right, you have a resolver or a client, right, and then that is talking to a recursive server, or what we call a caching server. And then in turns, recursive server, if you ask a question, if a client asks a question from a recursive server goes and talks to root name servers. It sends a query and asks for the question that the client is asking. So in this example, the client or the resolver is looking for the IP address of www.apnic.net, right? So it's looking for the a record, basically in this case, the APNIC web server. So the query now goes to the root name server, because the recursive server sends it to root name servers. And then in turn, root name server gives a reference. It asks the recursive name server to send the query to GTLD server in this case, because in DNS we have delegations under root level. So if you can see the root zone, there are other delegations to top level domains. For example, .net or .com or .edu and so on, right? And then the query goes to the GTLD server, and the recursive server sends the query to GTLD server asking the same question, basically the record of www.apnic.net. And then GTLD server responds back with another reference, which is in this example apnic name server. Now this name server is the authoritative server of apnic, because the record that we are looking for, which is the www record, that is in apnic.net zone, right? So the apnic authoritative servers should be able to give the answer about www record or the A record for the www and return that to the recursive server. So recursive server gets the answer and then pass it to the client back, in other words to the resolver. Okay. Now once the answer is given to the resolver, the answer is kept in the cache of the recursive server. So this is also why we call these recursive servers as caching servers, in other words, because it keeps the answers in the cache based on those TTL values. Now this is how a DNS query works. A simple DNS query. Okay. In this example, of course, we have not discussed about any security aspects and so on. Okay. So any server, if you send a query to any recursive server basically goes and talks to root servers or GTLD servers or the other authoritative servers and get the respective answers, what the resolver is asking, right? And it returns and keeps the answer in the caching server's cache. Okay. All right, let's move forward. Now, if you consider the DNS flow, right, or in other words, how this data flow across our DNS infrastructures, there are lots of data flows here you can see, but at the same time there are vulnerabilities, right? There are vulnerabilities because, for example, if you consider the different elements in this whole process, you have zone files. We write our zone files and then we update the zone files in our primary or master name servers. We do updates through dynamic DNS as well, right? Dynamic updates. And then these zone files are being transferred to other authoritative servers. For example, if we have primary server as well as, let's say, if we have some multiple secondary servers, the secondary servers, they come and get the zone files from the primary servers. This is what we call a zone transfer, as we know in DNS. So we have zone transfers. That's this number 3. These are actually transactions in a way, right? So we write zone files. That's number 1. We do zone updates through dynamic DNS. Number 2, dynamic updates. Number 3 is zone transfers. Secondaries get the zone files from primary. And then, of course, we have these caching servers, or what we call these caching forwarders, right? So you can see that these are our recursive name servers, where I have my pointer. So that's our caching server or the recursive server. So these recursive servers, remember, they talk to authoritative servers, either our primary servers or our secondary servers, and get the answers from them, and then return to the clients or the resolvers. That's number 5. The clients, they come and ask the caching servers or the recursive servers to find the answers. Now, according to the example that what we discussed earlier, when the caching server gets the answer or finds the answer after talking to root name servers or after talking to GTLD name servers and so on, and other authoritative servers, it finds the answer and then the answer is kept in the cache. For how long? until that TTL expires. So until that time, when the resolvers come, the caching servers answer from the cache, basically, whatever the contents in the cache. So you can see there are lots of these data flows in our DNS infrastructures. Okay, that's what we have, these numbers. Next question is now, okay, out of all these flows, which ones are not really secure enough, right? Which ones are not secure enough? Because do you think this zone transfers between these primary to secondary or master to slave, it's not safe? Yeah, that could be possible, right? Or even, what about these caches? How about someone modify the caches? Yeah, that's also possible, right? And what about these dynamic updates? When someone tries to update your zone file dynamically, what sort of risk involved? Yeah, so if you consider this DNS infrastructure, any place is not really secure unless we implement some security mechanisms. Everything is vulnerable, right? So this is why it's important for us to consider all these DNS data flows and to make sure they are all protected. In other words, our DNS infrastructure is protected, right? So how can we do that? Right? That's where we have to discuss in DNS security. Okay. So now, as you can see, there can be various vulnerabilities here. For example, someone can corrupt the data. Someone can write some wrong things into our zone files or delete the things from our zone files. That's, these kind of things, corrupting data. Or there could be some unauthorized updates coming through these dynamic updates, right? Or even impersonating master. Secondary might think, okay, it's getting this own file from the correct master, but in the actual fact, it may be not. Maybe there is someone else impersonating as the primary or the master. So instead of getting the correct zone file from the master, it could be getting a wrong zone file, right? In the same way, the master server could be thinking that, okay, I'm giving my zone file to the appropriate secondary, but if the secondary is not really the correct secondary, it could be giving it to a wrong server as well, right? So there is always a question of impersonation here, right? So that's why we have to make sure this transaction is protected. Then what about cache pollutions or data spoofing? Right? If these caches are being polluted, let's say in our previous example, when the resolver asked for www.apnic.net, recursive server gave an IP address. Now, if recursive server has been polluted to give a wrong IP address, then instead of giving the correct IP address of the correct web server, it could be returning a wrong IP address of an unknown web server, right? So these are the things that we will have to protect. Cache impersonations, right? So these threats that what we discuss can be categorized into two type of categories, and then we can protect based on those categories. One is what we call server protection, and the other one is what we call the data protection. So in one way, we protect our servers or the transactions, and the other way, we protect our zone data or the contents, right? So that's why you see here server protection and then data protection. Now for this, we have different mechanisms in DNS, different security mechanisms. Okay, we will discuss those later. So in the case of your cache poisoning, that's what we discussed so far. The client could be asking for a caching server with a certain query ID, And as I said, the query goes to root or the GTLD and to the appropriate authoritative server, right, which gives the correct query ID for that, right, and then it talks to the appropriate or the correct web server. But of course, as I mentioned to you earlier, if someone else, some third party, could pretend to be or impersonating, right, or spoofing and giving wrong IP address to those web servers. So the query, in this example, the query is coming for www.example.com, which is the correct IP address should be 192.168.1.1, but it could be returning number of other queries or the answers for those queries with different query IDs. And if it finds a match, right, these are kind of random ones. If it finds a match, then the recursive server can get basically polluted, right? So that answer in this example, the 192.168.1.99 answer could end up in this DNS caching server. After that, whatever the query is coming in can get 192.168.1.99 instead of 192.168.1.1. Okay, so these type of situations we are talking about, right? So what type of requirements are we talking here? We have to secure our name servers first of all. Now, name servers takes a big importance, right? A big importance in our DNS infrastructure. There are main three components we talk about when we discuss about DNS. We talk about namespaces, right? So that's your kind of zone file. So if, for example, zone files and so on, namespaces, domains, zones, and so on. And then who keeps those spaces? That's name servers. So we have to secure those aspects, right? And then we have, of course, the clients who are asking for these questions. So we have to make sure that these are all valid questions and answers and so on. Right? So now talking about various DNS server or name server softwares, we have various out there, right? There are open source ones, and there are other ones, commercial ones as well. So I won't go into too much details about the name server software, but again, it's all up to you, right? Whether to have an open source one or any other commercial ones as well, right? And then, but pretty much, most of these name servers, these softwares, they have similar features and so on, right? You can secure the queries, you can secure the zone transfers, you can introduce access lists, right? And so on. And one of the popular name server software is Bind, right? Bind software, and you can use Bind as well and do many of these functionalities, or these you can configure these, right? Now there are two important security mechanisms we talk about in this case. One is what we call TSIG, or transaction signatures, and the other one is what we call DNS Sec, or DNS Security extensions. Now we're going to discuss those things in more detail. So what is TSIG? Transaction signatures. Now in the case of TSIG or transaction signatures, our main objective is to protect the transactions. For example, if you remember the diagram I showed you earlier, the DNS data flows, there were transactions between primary and the secondary, right? I told you that the secondaries, they come to primary name servers and get the zone files, right? So the primary secondaries, they come to primary name server and get the zone file. But the problems over there, as we discussed, the impersonations. So we don't know whether are we getting the zone file, or secondary doesn't know whether they are getting the zone files from the correct primary, right? Or even the primary is not sure whether it's giving the correct zone files to secondary. The correct secondary could be given to someone else. So this is what we need to protect. Okay, so we will use transaction signatures, or TSIG, to protect this transaction. Okay, so as the slide says, it's a mechanism to protect a message from a primary to a secondary and vice versa. Okay, in other words, transaction basically. So how we do this? We have a keyed hash. Okay, in other words, this is a symmetric key we use. All right, so secondary, in other words, primary define this key or generate this key, and then it is being shared with the secondary. That's why it's called a symmetric key. So we have a hash here as well, a secret, right? So both parties need to know this. Otherwise, we cannot verify, the primary cannot verify the secondary, whether it's a genuine request or not. So it will wait for the proper verification. Okay. Now this is an RFC itself, RFC 2845. This RFC talks about these transaction signatures. Now this is the DNS data flow that I was talking about earlier. Now in this data flows, if you see these unauthorized updates as well as these impersonating master, these kind of transactions, they can be protected by TSIG. But things like data spoofing or cache impersonations, these or cache pollutions and so on, these are protected by DNS security extensions or DNS Sec. Okay. All right, so this is a simple, how the verification process happens. As you can see, you have master in one side, you have slave in the other side, or the primary and the secondary. Okay, so secondary comes query AXFR, that's basically a query asking for the zone, right? Zone transfer, because secondary goes and talk to primary and check whether the primary is synchronized or consistent with the secondary. If not, if the secondary knows that primary has got new zone data that is being verified by looking at the serial number, because in DNS we have to make sure that both primary and the secondary, they are consistent. Okay, in other words, how we maintain this consistency? Through the serial number. They have to have the same serial number. So when the secondary comes, if it finds the primary has got a larger serial number, secondary knows that primary has done some zone updates, so the zone transfer happens. So when this zone transfer happens, of course, least secured way is you don't have any security mechanism here. Whoever asking for zone transfer, primary gives the zone, but that is not good because you are giving your own zone to someone else without any verification. Another option is, of course, you can check based on the IP address. You can allow the transfer based on the IP address of your secondary. Right? But that's again, at least it is something, but not the best secured way, because still the IP address can be spoofed and so on. So that is why we would prefer something like a key or a hash, right, rather than an IP address. So that's what it's doing here. So if you see this slave, that comes with the key or the hash, right? And then the master verifies that, and if the verification process is all fine, then the master responds or allow the secondary to do the zone transfer. Okay, so this is how the transaction signatures verification process happens. So what are the steps involved in configuring TSIG? First step is, of course, you have to generate the secret. When I say you, means the primary server, right? If you are the primary for a certain zone, you generate the secret. Now, for example, if you take bind software, we have this utility called DNS Sec keygen. That's a utility where you can specify some algorithm, for you to generate these keys with a number of bit value. For example, you can come up with 128 bit or 512 and so on, right? You come up with a bit value. Okay, larger the bit value, of course, your key is more secure, but of course, the key is also quite big as well. And then you come up with a key name, right? You come up with a key name. Now, this key name needs to be agreed by primary and secondary. That's why we call it as a symmetric key. It's the same key between primary and the secondary, right? It's an agreed key. So once this is decided, then we need to communicate, right? Communicate the secret. How to communicate? Now, this includes, it's no point that we just send all the secret and everything into a very unsecured email and send it to the other party, right? So of course, if you're going to send this, make sure that you send it through some secure mechanism or out of band, right? If you're sending it through email, make sure that the email is encrypted and email is signed and so on, okay? Or use some out of band method to communicate the secret. And then you need to configure the servers. So when we do the configuration here, remember we are configuring the name server, okay? Now, there are two types of protections we talked about earlier. Remember, we talked about server protection and then we talked about data protection. Now, here we are focusing on the server protection side with transaction signatures. So that is why the configuration has to be done in the server, right? Or otherwise, basically in your configuration file itself. If you're talking from bind perspective, we are talking about named.conf file, okay? named.conf. So the configuration goes there, right? And then once the configuration is done, of course, we can do some testing. Dig is one of the utilities where you can easily do quite a lot of testing, right? Dig, that's the utility, comes with with the software as well, okay? Now this is just a sample configuration, where it goes and how it looks. So you have two sides of it. One is primary server and the other one is secondary server. Now this configuration goes into the primary side and this configuration goes into the secondary side. You can also see the IP addresses of primaries and secondaries, right? This is the primary server IP and this is the secondary server IP. Now here we are not showing you the full named.conf because named.conf generally consists of a lot of other zone statements and various other parameters and options and so on, right? And just for clarity purposes, here in the slide we show only the key statements and the server statement, and then of course your allow transfer statement here, okay? So in the case of primary, basically you have the key statement. This is to define the key. Remember we talked about a symmetric key. So this key name is the key name that you agree with your secondary. I'm talking, if you're a primary, right? Because we are in the primary side here. So if you're the primary, you define this key name. In this example, the key name is ns1 ns2.pcx.net, or for example, ns1.ns2. whatever your zone, okay? Try to give some meaningful name here, because if you give some various just random names for your key names, always you can get confused, especially if you're dealing with lots of keys, or especially if you're dealing with lots of secondary servers and lots of zones and so on. Because if you come up with a meaningful name, always it's much easier. By looking at the name itself, you know exactly this is my key key name for which name server, so which between what for what sort of transaction. Okay, and then it defines the algorithm you use. In this example, we use HMAC-MD5, and then the secret. Now this is the secret that you have after generating using that utility was what we discussed. Remember, we discussed the utility called DNS Sec key gen. The first thing, generate the key. So once you generate the key, you will have a secret. You will basically get two files. One file has got a dot key extension, and the other file has got a dot private extension. Right? So we are talking about two files. One file has got dot key extension, the other file has got dot private extension. So this happens in the key generation. Now if you open these two files, you will find the secret or that hash value. Okay, so since this is a symmetric key,